All right, this is the tutorial for how to do testing in ANSYS for senior design. I already recorded this once and it crashed, so learn from my mistakes. We're going to be saving at every step of the way, which is something I think you should do already because if it crashes, you'll at least be able to pick up, and that's something that can happen here. So we're going to open Discovery AIM, right click, and if you have the option to run it with a graphics processor, make sure you do that. You'll see that option right in here. It'll make the testing a lot faster and easier for you. But if you don't, that's fine. Just go ahead and open it or run it as administrator if you're running into some issues. Running as an administrator normally fixes those. For me, I have it open already because it can take about a minute and a half to load, so I want to save you some of that time. We're going to be opening up the electromagnetic simulation. It's this green one here. It keeps flipping when I hover over it, but it's the green one. Electromagnetics, start. And we'll switch to full screen here. We're going to import a geometry file, and we're going to make sure that allow geometry modeling is open. Now, I've got one pre-prepared a little bit, so this is where you'd be using one of the assemblies that Maddie or I or CJ have made, or if you are Maddie or CJ or me, you can use the ones that you've made. You're going to want to make sure that it's a step file. So down in properties here, I can see that it's a .stp file, not a .iam file. So up here, test demo Autodesk Inventor assembly is, if I open that up, that's a .iam. That's the Inventor file. Down here we have the universal file. And for me, it's showing up as SolidWorks. It might show up as something different for you, but make sure it's a .stp. And open that, and it's going to import. It might take a little bit to import. Go make yourself like a pot of coffee. A lot of the steps here take 30 seconds between each step, but over time it adds up. It's just kind of how it is. Kind of sucks. Over here now we have our model imported. If I hit Control and then middle mouse button, I can translate the model up and down, left and right. If I push Shift and middle click, I can zoom in and out. And if I just press middle click plainly, it rotates the object for me, so I can see different views. And as you can see, this is a model with one acetabular magnet. And if I hide this body real quick, you can see there's one magnet on the inside. I'm just going to show all. Over here, we want to select permanent magnets as our magnetic source, constant temperature. Do not select compute force and compute torque yet. We'll be doing that later, and I find that when I select them in here, it just causes headaches down the line as it tries to figure out what we're trying to do. We'll want to create surround automatically, and we can stick with air. We might want to use something like water, or something that mimics muscle tissue, but for the most part, I thought water would be something that closely mimics the muscle tissue, but when we open up the data, the numbers that the program's using, it uses the same numbers for air and for water and a lot of other materials, so it shouldn't actually mess with the magnetic results. Over here, number of bodies to assign within the solid region. We can just use all unassigned bodies, and it doesn't actually matter what we select here. We're going to have to go in and reassign these manually. I'm going to use titanium alloy. If you don't have titanium alloy like in the default menu yet, it doesn't matter. You could use copper. We're going to go back in and reassign them manually. We have to do this because of the magnets and things like that. It's updating. So now what it's done is create this giant cube of water. Why it does that is because it's trying to figure out how far it should map the magnetic fields. So in theory, you could have a slight magnetic disturbance a mile away, but we're not interested in that. So it's creating this default boundary in which it's going to compute the magnetic fields. And if I go over here and make sure I use body selection, I can left click the cube, select it, I'm going to go into physics. And then, so in physics, if I left click to select and then I right click, I get this option to hide the body. So this is just going to hide that cube of water, and here we are left with our model. And as you can see, it changed from that kind of gray color, that matte gray color, to a shiny metal because it's trying to mimic titanium. Now, before I continue, like I said, it crashed on me once before, so we're going to Control S to save, or just right click up here to save it. I like to save it in the same folder where I got my model, so for me that was in ENSC models with the current date, unique models, and then for me it was just under assemblies. As you can see, I have 2 that I was running for the presentation to get some of those pictures. But here we'll just call this test demo, and then I'll underscore test demo project. And now that'll save our analysis. Cool. So now if something happens, we can always revert back to this stage in the test. One of the things I want to talk about before we get too far in, we're about to do material assignments, but first, physics options, and we can go into physics options and change the temperature. Now I find if you forgot to do this, it's no big deal. It doesn't meaningfully affect the test, in what I found that the change is very minimal. But we want to make sure that we're as accurate as possible, so we'll be modeling the ambient temperature as 98.6 degrees Fahrenheit, close to human body temperature, rather than 22 degrees C, which is, I want to quick look this up, 22 C to F, 71. So as far as magnets go, not a huge difference. If you were off by hundreds of degrees, it would change the magnetic fields and stuff and Curie temperatures. But for us, it doesn't matter too much. But we want the accurate number. So that's the physics options taken care of. Now into material assignments. So right now we have our air assignment, our volume, and then we have our titanium assignment of the 6 volumes. I'm going to go ahead and delete this titanium volume. And now we're back to that because we're going to have to do magnets anyway. So I'll do the titanium alloy. You can search if it's giving you problems. Let me know. One of the things you might have to do is go into this projects tab over here, engineering data, and then you can go engineering data. Excuse me. And then not import. I don't see what I'm looking for, which is a place to open up the engineering data and, well, there we go. That's what I wanted. So going here, right click, edit. That opens up this tab, and then we can go into engineering data sources. So if you don't see titanium alloy, you can find it under engineering data sources. So, well, first off, so if you don't see titanium alloy in this tab, go up to project, go to engineering data, right click, edit, engineering data, general materials, and then so general materials, and then in general materials I can go down to titanium alloy, and that has all of the parameters we need. We can add it. And then now if we go, if I click this engineering data, it brings us back to the engineering data we've selected for our project, and we have titanium alloy in that menu. So I'll go ahead and close it out of that for now, and go back to assigning materials. So material assignment, titanium alloy, we'll go ahead and click this. We need to go up here and make sure we're in body selection. If I, for instance, click edge selection, or edge face selection, and I select this edge, it'll it'll think that I'm just selecting the outer face of the, in this case, the acetabular cup, which is not what we want. We want the body selection, and this way it actually reassigns the whole volume to the material we want. So I'm going to select that and add it. There you go. Now we've got a volume, one volume of titanium. So now our acetabular cup is titanium. We'll do the same with the polyethylene liner. Now, even though it's polyethylene, in that engineering data, they're using the same numbers for a constant called the isopermeable relativity, which is a magnetic parameter that happens to be the same for both polyethylene and titanium. So for our case, we can just use titanium, save us a little time, because we know that the results will be actually identical because it's using the same numbers behind the scenes. And I'm just selecting a material and adding it to the selected entities. And there we go. So now I know it says next step here. I found this to be really misleading. So I recommend, instead of going to next step, just go down to clicking physics. And now you're back at that home page. So we can go physics material assignments, add a material assignment, and now we'll do NDFE30. If it's not, you can just search NDFE30, and then we'll be using 30 for this. Material assignment, NDFE30. Now we can rename this if we want to make it easier on us later. So I'll just call this femoral head magnet. That won't affect the results in any way, but it just keeps it easier for us when we're kind of doing some bookkeeping if we need to troubleshoot or anything like that. Add that body. So now what it's done is, by default, it'll use the x-axis, so that that's the red arrow in this. You can see down here in the left corner, bottom left corner, x is red, z is blue, y-axis is green. So by default, it creates a magnetic field in line with the x-axis, but that's not what we want. We want it to be in line with the magnet. So we're going to create a new reference frame. I'll call this reference frame, something like femoral head frame. Again, just to keep it easier on us for bookkeeping reasons, trying to make sure we know what's going on if anything goes wrong, and we can troubleshoot it later. So down here, we want to select based on geometry selection, and first is the origin location. If I select the body of the magnet and then add that, what it does is it uses the centroid of the body as the origin of the axis, origin of the reference frame. Then next we need to define our first axis, so we can define the x-axis based on geometry selection. Now this is one of the few times I like to use the face tool. What we can do is we can select the top face, and it'll just create a axis normal to that face through the center point. Perfect. Now here, what it did automatically was create an axis pointing straight up, which for me, I like to have it pointing towards the magnet. I can kind of think repulsion, north, kind of positive. So I like to have it pointing towards the repelling magnet, and I can do that just by clicking reverse direction down there. Now it creates the second axis automatically. If we needed to specify that, we could, but for us, we don't really care because we just need this one magnetic field pointing kind of straight down, and it uses the x-axis for that anyway. So now going back to the physics tab, material assignments, now we need to add a material assignment for the last magnet on the inside, one of the ways we can get that, going back to the body selection, select this, right click, and now hide it. That way we can access this magnet on the inside. Add a material, add our magnetic material. Go ahead and rename this something like, I named them wrong, didn't I, last time? Femoral head frame, or femoral head magnets. That's fine. I'll just make sure. I'll just go back and change those so that they fit. Okay, select this body. And now click add. And now it's being treated like a magnet. We need to create a new reference frame. Yep, I named it wrong last time. Why don't we call this fem head frame real, the actual one that should be on the femoral head. Based on geometry selection again, select this magnet and face. Again, I'm using the body select tool. If it's not working the way you think, make sure you have the right tool selected. Down to now that we have our centroid, we want our x-axis based on geometry selection. Switching to the face tool. Now, last time I picked the top circular face for the other magnet, and it created an axis normal to that plane. What I'm going to do this time, just for demonstration purposes, is select the outer face of the cylinder, neither one of the circular faces, but the kind of the wraparound face, and I'm going to use that as my face. Now, because I have calculation methods set on automatic, it used the kind of the right hand rule to create an axis. I think you could say collinear or coaxial to the cylinder. But either way, it'll work. So just so you know, like if you can't, if something's wrong with the top face, you can use this side face and it'll still calculate an axis for you just fine. Now, again, I got to reverse the direction here. So before it was pointing straight down, I click reverse direction. Now it's pointing up, which is what I like, so that we know that they're both repelling. And then we're good. Go back to physics. Now, I made that mistake with the reference frame earlier. So I can go into auxiliary definitions, reference frame, and I'm just going to go into this what I called femoral head, which was wrong, and call it acetabular frame. Going back to physics. There we go. I think we talked about solver options already. If we didn't, let's just do this real quick. In solver settings, we can change between speed and accuracy. For us, our geometry is small enough, and it's few enough parts where this isn't too it's not too bad. We can lean towards speed if your simulations are taking a long time and giving you trouble. And I think once we hit some of the most promising ones, we could retest those with a little more accuracy for maybe the top few, just to make sure that our numbers are really accurate. Down here with coarse meshing, you don't really want to adjust that. What it's doing is the way it runs the analysis, it breaks it up into a ton of little pieces, finite elements, and it runs the calculations on each of those elements, and the whole set of those elements is called the mesh. So, for example, the spherical femoral head, it's treating that like a lot of little pieces, a lot of little rectangular pieces, and then adding them all together. Now, one of the things we want, I'm actually going to Control S here, make sure that we save it. Now it's going to say out of date. Don't worry about that yet. We don't need to update it until we have our parameters. So like what we're solving for. There we go. Physics options, force computation. So let's select force computation. We can just leave it on virtual. Yeah, we'll just leave it on virtual for now. Location, we can select a body. So let's select our femoral head magnet. Add that. In the reference frame, we can leave the reference frame as the global reference frame, because what that's doing is just telling us which direction the force is in. And so if we leave it in the global frame, that's fine. We can do the same for torque, but I'll skip that just in the sake of demonstration. Just for save us some time. Now we're solving physics. Now this may take a while. This is probably the most computationally expensive step. And so you want to make sure that your setup is right. Now you might be thinking, Joey, where are the rest of the pieces? Where's the acetabular cup? Where's the liner? Well, they're all still in the physics simulation. It's still running just like it would as if they were all visible right now. I just have them invisible so that I could access the magnet on the inside of the femoral head. There we go. So now it's making its initial mesh. It was probably, like I said, one of the longer steps. I can try and just fill the air, but not my specialty. There we go. So our physics is solved. Let's just right-click Show All, just so we can see the whole thing again. Now I'll select Body, select this cube, right-click, hide the body, just so that we don't have to be staring through kind of a random airy cube the entire time. Clicking that ball shift us to an isometric view, can help to see some of the things sometimes. I kind of like, no, not that one. I like that view, so we can kind of see the thing. Now, if I click, before I click results, I want to show one other thing we can do. Going all the way back to geometry, we can go into something in the edit geometry, and this is AIM's geometry editor. So in theory, you could build the thing entirely in AIM, but it doesn't have the tools that Inventor has. It's a bit clunky. I'm not really a fan. Over here, we have the same thing. We can just hide the air so that we can just hide the air so that we don't have to look at it. It's still in the simulation. It's still there, but we don't have to look at it, and it makes selecting the parts easier for us. Now, what I'm going to do is I'm going to go into group. Oh, I'm not going to go into groups yet. It's kind of acting a little weird. There we go. we can go into Edit, Move. So what I'm going to do here is try to select. I'm going to drag and drop to select. Oh, I'm going to drag and drop to select just. Oh, that's not what I wanted to do. Ah, this is the way to do it. Sorry. Weird tools. So we have, so in here, so what it's done, so when I click the bottom of the femoral head, for example, it creates this little orange box around the part. Now that's in the geometry editor, that's how we know that we've selected a volume. If I drag and drop over that part, we see all of this orange selected, and what's actually done there is select all the faces. So that's not what we want. We want to drag, shift, and then, or sorry, we can click over here. We want to select all of the femoral head pieces. So that's the magnet, the magnet inside the femoral head. Shift that up here. So femoral head top piece, femoral head bottom piece, and the magnetic core. If you had those two multi-diameter magnets, you would want to include them too. We click that, shift, and then press the down button to select the whole set. So now we have the top of the femoral head selected, the magnet selected, and the bottom of the femoral head selected. We can click this move tool, and now what it does is it gives us this axis. Now, as the person walks along, we can actually change this value. So, I'll click this x-axis so I'm in line. And then by clicking this little arrow here, we can change, we can rotate it along. So if I rotate just a little bit, you can see it moved all three parts. So it moved the magnet, it moved the bottom of the femoral head, it moved the top of the femoral head, and it moved the magnet inside as well. If I click this P button here, P for parameterization, it will parameterize that for us. Now, I've had a couple problems here, so I think it would be super helpful if we could troubleshoot this. When I do it, for some reason, it moves. So right now I have 0.6 radians selected. It moves 0.6 radians every time I run the test, which is not what we want. We want it where it moves like 0.6 radians in one test, and then maybe I'll say, instead of 0.6 radians, move, 45 degrees. You just put 45 degrees, and it'll convert. It's using radians by default, but we can type in DEG to use degrees. And so what we'd like is to say, all right, 45 degrees is like this. That's good. But now it behaves real weird. This dimension, this group 1, I can rename it to just angle. This angle we're back to 0.6. What? That's not 45. But we're still at this weird angle. And now if I try to go back to 0, we're at negative 0.3 radian. Like, we're going all the way around again. So something is off with this. Another thing I've noticed is that if I use this tool multiple times, one of the things that can happen is it shifts. So if I go all the way around, it moves it from its axis. Right now it's no longer centered. So whatever I'm doing in this parameterization angle thing, something's wrong. And if anyone knows how to troubleshoot that, it would be greatly appreciated. Gonna undo our parameterization just to demonstrate. But that was one thing I wanted to make everyone aware of, is that that's one of the things that I'm having problems with, is finding a way to parameterize that so that we can we'll run the test throughout the person's gait, throughout the person's walk cycle. Going into physics, we have our force computation and our physics options. We can go into results. Now, it has two sets of results. It has the vector results, which are the magnetic flux density. So those are the arrows and stuff. Backspace. The contour results are the magnetic flux density. The other one's magnetic field density. We can evaluate both of these. They're time intensive. But one of the things I want to do is add a force magnitude, and now it's automatically selecting the one force magnitude. If we had multiple force computations, it would, we need to select which one. The function here is just the value. If we had parameterized it in the geometry, you can actually go in here and select parameterize, and that way you can get the force as a function of the angle. But right now we don't have that parameterized, so I don't have that. We are just right for this test with just the one magnet. The force magnitude and the force in the y direction, along the green arrow down here, are going to be the same. But if we had, let's say we were running a test where this magnet was at an angle and we had like magnets on the side here, the total force magnitude and the force broken down amongst the components wouldn't be the same. So that's why we have that option there. Going into results, I'm going to evaluate everything. This is going to take a while, so we'll just have to ad lib. One of the things I should have done, and I'm realizing it as it computes, was saving before running the results, because this can crash, especially because I'm recording this. So I'm just going to let it sit and do its thing. Update for task solve failed. Let's view these messages. I can open this up to see it bigger. See the error messages cannot. Now these errors, sometimes running different tests, I get different errors. One error that it can sometimes say is solver failed to converge. In that case, if we were running a super intense simulation, we would care about that. For us, what that normally means is that it just didn't hit the convergence that it set, but our test results would still be good in that case. In this case, it looks like the error that I have is exclusive access required. So I'm going to just press Control S to save it again. But one of the ways that could be fixed is just by running it as an administrator. So I'm not actually that worried about these errors. If you see an error that you are concerned about, make sure to text the group. These errors, command execution, it's letting me know that it failed to converge, but we can actually go in the solution monitor here and see it's converging down. It's just, it didn't hit that tolerance that it's setting by default. So I'm actually not worried about that. Let's open up our results and show some of the things. So we can see there's preceding tasks. Great. Well, I guess we get to see Joey try to troubleshoot a thing live. Attention required. Details. Conduction path is conditionally up to date. Let's see if this geometry is all good. Conduction path. Materials are assigned correctly. the raw? Yeah. Let's let it run. Oh, it's evaluating something. Project is locked. I have never had that result before.